mainly mobility simulations of full vehicles. Occasionally it could be operation of some tool moving soil, but most of it is wheeled or tracked vehicles on soft terrain, so for mobility studies. In most cases we didn't do it at all, and in some cases we could use quasi-static parametric soil models, the typical Becker-Wong model or similar to that, but they don't capture the dynamics of the soil tire or soil track interaction. We can predict in a very different way how well our vehicles will perform in real terrain, and it helps us dramatically to tune active control systems that directly interact with the dynamics of the terrain, both traction control ABS models as well as active suspension models, and what's coming now more and more central tire inflation systems, who tend to become faster and faster with the years. You don't have to stop for 5 minutes to release the tire from the air. Now you can do it while you're driving, but it might still take you half a minute, and you can get very different dynamics if you drive out off-road while you're lowering the tire pressure dynamically there. The main strength is the enormous knowledge about soil particles and the modeling of soil to get a cohesive model together for the soil, and all the work we've been able to do together to interact between EDEMs and EDEM in a very efficient way, and the way we're working together now to set up a flexible tire to work together between an MBS code and EDEM. Future of simulation is twofold. One is co-simulation. Everyone talking about co-simulation these days. We have left the stage where one tool could do everything. It's very important for us to be able to co-simulate between different sciences. The multi-body programs, the tire codes, the soil model. When we push, well, soil model is just the start, right? We're working still with relatively large element, in best case down to millimeter size. But we want to be able in the future to do silt, mud, even maybe water. So then we're talking co-simulation with CFD code, and there is potential that we want to have really wet sand that behaves very different than dry sand or gravel, where we really want to model the water being pushed out of the soil, where you actually have a very, very high dynamic stiffness of the material, but the static stiffness is really lousy. So if you're driving over it fast, you have a hydrodynamic support in your sand, but if you stand still, the water gonna be pushed away and you're gonna sink down. So there we see a co-simulation between the multi-body and tire code with EDEM and a CFD coupling in the same loop. That's one of the two things I see for the future. The other big thing that's coming is artificial intelligence, machine learning, that we can use different technologies running a limited set of simulations and then have a machine learning to quickly repeat this system behavior with a different set of parameters. Let's say we run 10, 100, 1,000 runs. We learn from these runs, or the machine will learn from these runs, and now we can repeat basically the same thing in a second and get the same or very similar time history for any other parameter combination. this is really necessary in the future, where we want to be able to look at the road, maybe from a helicopter, airplane, satellite, drone, whatever, maybe use a ground penetrating radar, looking a kilometer ahead of the vehicle, detect if it was raining last night. Now we have different properties. Maybe we're going in terrain we've never been in before, but we want to compare this ground penetrating data with a database of soil, very quickly replicate simulations over this soil for the vehicle system, and see, is it doable to go there, or am the riverbank gonna collapse under me? I have to find another road that is safe but takes 3 times as long to drive over. So that's the 2 big areas. It's co-simulation of complete complex system, and it's machine learning of those systems for quick replications.